Hi. So this video is going to be about how to make a car with square wheels in nbphysics. If you don't know what nbphysics is, it's a physics engine that I made in GameMaker Studio. It's free to download on my GitHub, and here's a bit of what it can do. So, and, the GameMaker version that I'm using is the LTS version. Okay, so why am I doing this? Well, this is going to be like a series of tutorials of just random physicsy things that I feel like could work in using this physics engine. But yeah, I haven't actually made this. This is going to be sort of to see if it's possible, I guess. And these tutorials are going to be very practical. So they're not going to, I'm going to explain a bit of what I'm doing, but they're going to be like very, I wouldn't say quick, but you can just follow along, do exactly what I'm doing, and you should be able to get the same outcome that I am getting. So the whole idea, I don't know why. I know why I'm doing this, but so we're gonna make a car with square wheels. Why square wheels? Because I know if they were circular wheels in the current engine, there's no friction. So we would have to sort of fake a friction force, which I can definitely do, but this is sort of like a maybe like a showcase of what would happen with rotations. Like what happens if this rotates and hits, say, like a floor here? Like how does it actually move? So yeah, that's gonna be the goal, to just make this car. We're gonna have a wheel object that's gonna spin. We're gonna have another body. It's not really gonna actually it's not even really required, but just the two wheel objects that are kind of connected with probably like a rod or a cable, and they're gonna hopefully, depending on the rotation, go either right or left. So that's going to be the idea of this. Okay, there you go. So I'm gonna start from like square one. Like you have nothing, but you have a GameMaker. This is what I'm gonna do. So step one would be to actually download nbphysics. So you'd go to this websites, go to the releases. You can download it from the code as well. And I'm just gonna download this version. So the nbphysics here. This is the local package that you're gonna be able to import into the engine. So here it is there. Now to create the new project, so I'm going to create it. It's going to be called, I guess, car with square wheels. Okay, I'm going to save it in the tutorials, and there you go. You got a new empty GameMaker project. Step one is I'm going to actually create a GitHub repository for it. It's a pretty important thing to do whenever you're making projects. You don't have to do this. This is for me to help you guys as well. Whatever I do will essentially be put on GitHub, and you can see the actual code. So I'm going to go to tutorials, car with square wheels, select add a local repository, create a repository. Um, I guess we can just keep everything as is for now. I'll probably change it later. The license, I guess, could be MIT. Okay, create repository. Okay, so you have the repository. I'm going to publish it to GitHub, public. For now, we can change that later. Okay, so whatever I end up doing will be shown online. You can download the code there as well. All right, get started. First, we're gonna just create the scene. So when we press play, let's see what happens. It should just be empty, right? Okay. So we're gonna actually first we're gonna import the package. So we're gonna go marketplace. No, tools, import local package. Go to downloads. Find the nbphysics. I'm only going to download the bare necessities of, so that's going to be the scripts folder with the vectors and matrix structs, the physics stuff, which is like force generators, content generators, trigger generators, all that stuff here. We also need the objects specific to the engine, the physics world, rigid body, and the trigger. We don't need demos. Notes is useful if you want to read about the thing, and we don't need any of the rooms. Okay. And we do need some sprites because there's some default sprites that are set up for the objects. We're going to import those, and there you go. Okay, so when I press play, nothing should happen still. What I could do is create a room, which we already have a room created. We're going to go and put the first couple of objects just to see what happens here, and just like this. And I guess create a physics worlds. Doesn't really matter because it's not going to be counted for, but there you go. We have a physics world, tells you there's one rigid body, and the rigid body here is asleep because of the purple dot in the middle, and it's also a rectangle. Okay. Step one, we're going to create a wheel object, right? That's going to rotate. So I'm going to start with making an object here. It's going to be called O wheel square. Okay, then I'm going to make inherit from the rigid body because it's obviously a physics object, and the rigid body is a physics object in this physics engine. And then we're going to assign it a sprite. In this case, I'm going to assign it a rectangular outline. And I'm going to place it into the world. I'll delete this one for now. Go like this. And just make it this size, I guess. Doesn't really matter. Okay, so for press play, it basically be the exact same thing that would happen with the rigid body because there's no logic change. So just to make it different, we're going to rotate it with, we don't have a step event here, but we can add one here. The reason why there's no step event here, but there somehow this thing moves is because all the physics is run in the physics world. So that's why that happens. It also runs in the step event too, so good thing to note. So we were going to rotate wheel. And that's basically just image angle plus equals 1. But we can have some sort of speed here that we can inherit here, go like this. And we're just going to go rotation. Rotation speed is equal to 1. And I like to use, what is this, camel case? Just because if people, I mean, if you use, what is it? It's not snake case. I think it might be snake case, but I think GameMaker uses that when you do like stuff. So yeah, like if you ever end up writing something that's moving collide, for example, but you use this, you cannot because you have to compete against GameMaker's functions. So that's why I use the. All right, whatever. That isn't really important. So we're in rotation speed. Okay. So now when you press play, it should rotate. Okay, it rotates, but it is a rectangle that doesn't rotate. That's because it uses the bounding box. In this engine, I support 3 shapes, which is a rectangle, a rotated rectangle, and a circle. So I'm gonna change the shape to be a rotated rectangle. So we're gonna go nbp, and of course, one of the things that happens is it doesn't autocomplete when you initially import the package. So just to make it easier for me, I'm going to close the project. I'm going to open it back up. And this seems to, I guess, call whatever GameMaker stuff that is required for the auto fill stuff to actually work. Okay, now if I actually type in nbp, there you go. I don't know why it does this. nbp change shape. So it'll be set shape, I think. Okay. This will be self.id because it's asking for a rigid body, and this is a rigid body, and we're asking for which shape. This would be shape, nbp shape dot rectangle rotated. All right, one thing I just remembered, if I rotate it like this, it doesn't actually rotate the or update the orientation matrix, which is used for collision calculations for rotated shapes. So to do that, we would have to use nbp set angle self.id, whatever the angle is currently, which is image angle, plus the rotation speed. Okay, so just to show you what this does. Yeah, so basically it does exactly what the other thing is, but it also, if it's a rotated rectangle, which is what our wheel is, it'll update the orientation matrix, which is important for the calculations for the rectangle. Okay, so now when we press play, it should actually, this one wouldn't, I guess it doesn't really matter right now, but it should rotate as a rotated rectangle. Okay, that's good. Step, I'm not sure what step that was, but all right, next step is, I guess, just place it on the floor. Or, yeah, place it on the floor, put some gravity, link it to another wheel, and then, yeah, have a controller that can drive it around. So, we'll just go, easiest one be gravity, I guess. So gravity dot y is going to be equal to 10. It's a built-in gravity thing for the rigid bodies. If you're ever curious what's in a rigid body, you can just go to the parents, the actual rigid body itself, see what's there, and there is a gravity vector. Okay, gravity dot y is equal to 10. Positive y is downwards. Might as well press play to see what happens. And it doesn't go down. That's because gravity doesn't function like a force. Right now, the object is asleep with a pink dot. To wake it up, you would need to either apply a force or set it to where it never goes to sleep. Or you can start it off awake as well. Actually, that's yeah. So I'm just gonna wake it up. Uh, wake up, wake up. We're gonna go nbp set awake equal to self.id, and then we're just gonna go true, and that should wake it up, and you can still go to sleep eventually, but it won't because it moving objects don't go to sleep. And yeah, there you go. So there's the gravity. Okay. Next is going to be adding a floor. Very simply, I'm just going to make another rigid body. I'm going to call it floor. Floor, and we're going to go also parent is going to be the rigid body, and then we're going to find a sprite for it. Doesn't really matter. Then we're going to go here, go here, go here, go like this. Okay, so what happens here, if I don't change anything with this, when this body hits this, it'll go down as well. I think because it'll wake it up. Or actually, no, it wouldn't because... Actually, oh yeah, that's true. It wouldn't even collide because collision is not set up yet. That's true. So we're going to do that. I'm going to go into the... I guess I'll just do it here. So we have to have a place that holds the collision generator as well as when to link it with everything else. So I'm going to do it. I'm going to create the collision generator in the floor. So we're going to inherit here. We're going to create our contact generator actually. Generators. We're going to go CG for contact generator instance as an instance contact generator. It'll detect collisions between instances. So we're going to go new contact. Actually, it's called new inst contact generator. Okay. Then we're going to link this with the wheel in the room start event. So this ensures that the creation event already ran with the wheel and everything's good. Here we're going to link RBs, I guess. So with all the wheels, because we're going to have more wheels later, we're going to go other. Actually, we're going to use nbp add contact generator. We're going to pass in the rigid body here is going to be the wheel itself, so that's still self.id, and then the CG, the contact generator is going to be other.cginst. All right, so this allows for collisions between the wheel and the floor, or this should allow for it. So let's see what happens. And the floor should fall downwards when it gets hit. There you go. Okay, so the reason why that happens, for starters, the floor isn't experiencing gravity, but rather it has a mass, and when it collides, there's collision resolutions that happen based off of the masses of the objects. So if you don't want the floor to move, you'd have to set the mass of the floor to be infinite. So that's what we're going to do here. We're going to set mass. So I think there's a function for that. Or you can just go inverse mass, because rigid bodies, they store the inverse mass because it's faster to do calculations, because most of the physics stuff you divide by mass. So inverse mass, you just multiply it. So setting the inverse mass to 0 essentially means you're setting the mass of the object to be infinite, e.g. you're making an environmental object here. So this should allow the hit. Okay. All right. There you go. So it's on the floor, it's rotating, but it's not moving in any direction. So that's already a bad sign. That might mean that I'm gonna have to do some more work for that. Let's see here. So, okay, let me think about this here. Let's go to the right. I wanna go to the right direction. Um, I guess we can also just go rotation direction is equal to -1. And I'm just gonna times this. Okay. All right, so let's see. First, I feel like my idea right now is if I make the floor into little pieces, it'll catch onto the sides, and when it like rotates, it'll push it in the direction uh, that it catches. So that's what I'm sort of leaning towards here. That would also mean something like making the floor very rugged. So, I can make another floor object, or I can make I'll make a rock object actually. Oh, rock. And I'm gonna just put a thing here. I'm gonna go parent. It's also gonna be rigid body as well. Bum 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 bum. We're gonna go here, parent, and this rock itself is gonna just be placed, I guess, here. We can go make it bigger. Maybe it's a little too big, but let's change the size to be like 8, or I guess maybe 16. Okay. And snapping direction, just okay. So rocks will be like this small. We'll see what happens there. And we'll just kind of litter them around. What is a better way to do this? I will just test it, see what happens. Okay. I'm just curious to see what happens. Oh, it's not going to collide because they're not connected. So we have to go to the floor object here, and as well as the wheel square. You might as well actually do all the rigid bodies. So just go rigid body, and they'll all be, that also includes the floor too this time. All right, nice. So there's some movement. These guys are not affected by gravity, so we're gonna change that. Let's see what happens. We go, um, that's just init. We're just gonna go gravity dot y is also equal to 10. We're gonna go inverse mass is equal to very, very low, which basically means very heavy rocks. And we'll also add some damping so that they barely move. This multiplies, this gets multiplied by the velocity every frame. So the smaller this number is, the more it takes off of the speed. So that should prevent the rocks from moving a lot. There you go. Okay. Also, this is it's like pretty bouncy as well. let's prevent that from happening by changing the bounciness to be 0, as well as bounciness from the floor to be 0 as well. And we'll also go and do the wheel, because the bounciness is it gets used in collisions as well, but they're averaged based off of each thing's bounciness. Oof, it's looking harder than. All right, so these have to be environmental, I guess. Let's just make it environmental so they don't move. So we don't need to do any of this stuff here. Yeah, let's make it 0. And let's go like this. This is all about exploring what the engine can do right now. The limitations of this engine as well as, okay. Yeah, there you go. So it barely catches on. That's what I was expecting to happen. All right, so the faster the speed, maybe the higher the gravity as well. So actually, let's also space this out a bit more. So we're gonna go like this, maybe 2. I'm gonna find the perfect distance between these. All right, and then having acceleration on the wheel spin would also allow for different rotation speeds, which would help. Nice. Okay, let's go. Oh wait, also I remember a video saying that maybe like circles actually would be better. So let's make these rocks into circles. So we're gonna go to the rocks and they set the shape to be circles. Shape. So nbp set shape. Whoops. Self.id. And we're gonna go nbp shape.circle. Let's see what happens there. Okay. Maybe making them bigger actually would work. Like that maybe. Whoops. These are squares. Sick. Okay. That kind of works. And we can just kind of go all around. I'm gonna just fill all these up. Oh no. Oh, I guess we'll just go without. Also, maybe we don't even need the floor at this point because these are kind of floating. Okay. Spaces of 2. Okay. And after this one, I'm gonna start working on changing the driving speed. Okay, it barely clears. Interesting. Okay. All right, let's get started on the actual driving part of it. So for starters, we'll have a car. So we're gonna have a car object. So we're gonna create a car. So a car is basically gonna spawn 2 wheels, link them together, and controls the actual driving of the thing. So step 1, instead of actually putting this guy here, we're gonna put a car here. We're gonna just place it there. It doesn't really matter what. We can draw a little car sprite real quick. This is gonna be very crude. S car, we're gonna go. It's obviously it needs to be kind of wide, so 128 probably. Whoops, that is the wrong direction. 64, 28. Okay, we're gonna go middle, center. We're gonna edit this like this. We're gonna go like this. Square wheel for pockets. Okay. Front. Let's make it. Let's use more math to actually draw nicer, maybe. So we'll just go. At this point, we'll just go like this. Go like this. Let's go like this, no matter. From here to here, here to here, here to here, and then here to here, here to here. Oh, just go from here to here. Okay, and I'll just draw a window. Little other window. Okay, I'm gonna try it too much here. And I'm gonna just go the door. No. Alright. Actually, let's probably make it as simple as possible here. That's fine. Okay, that should be okay. Most important part actually is making sure that it's the correct size. It's too small. It's still pretty small. So let's just double the size. Doesn't really matter. 28 pixels are gonna be double the size though. It's fine. Okay. It's about, whoa, it's pretty good. Okay. There's the car. Next step, spawn the wheels. This is going to be like, not even, doesn't even, actually let's change the color so that we know how the layering looks, because they're both going to be whites. Actually, they're not going to be both white. Just still change color though. Let's go like this, go like this, go like this. Okay. Next step is to, I guess the car actually will be a rigid body. We'll probably place a rigid body in the middle of it that isn't affected by gravity. It gets pulled by both other wheels. All right, let's see how that works. So we're gonna go create, actually we'll just go parents, make it a rigid body real quick. But it will use the actual, I guess it doesn't matter because, okay, that's something important. So we don't want this to collide with anything. So we'll have to change that. So for now, that's fine. Okay, let's get started. This will have to create the wheels. So we're gonna go left wheel is equal to instance create layer. It'll be we'll go x minus, just go 32. Most of you were off what that is, and then y, and then we'll just go instances. You're gonna go wheel square. Do this again for the right wheel. This will be in the other side. Okay, so this creates both wheels. Doesn't actually link them with anything, so we'll have to link the wheels. Let's try doing it without this being a rigid body first. Okay, and we'll just make the x and the y the average for now. Pretty crude way, but I think it'll actually be okay. So every step we'll just, for starters, we create the wheels. We have to create the link between the wheels, which will be a rod, most likely. Yeah, so that would be CG rod is going to be equal to a new rod contact generator. We're going to pass in two things, two rigid bodies, the left wheel and then the right wheel. I'm always a little hesitant to use rods because they end up doing a lot of collisions like really quickly, but we'll see what happens. The distance between them is 64 right now. And the wiggle will just go 0.1 for the actual collisions. Actually, maybe just go 1, make it more. Alright, so it creates the wheels, they fall down, rod is there. Every step events here, we're gonna basically set the Y to be like whatever the things are. So we're gonna go Y is equal to, is there an average function? I'm actually curious. No, whatever, we'll just go left wheel dot y plus right wheel dot y divided by 2. That would be the average, right? Yeah, that'd be the average. Let me just do the x first. But the x though would not be what we want to be the average. We would want the middle point for the. Actually, do you want the average or the middle point? Or would it be the same? Okay, the x average, wouldn't that be the same? Actually, I think it would. Okay, let's see what happens. So x and y, this is not a rigid body. It creates two wheels, has the rod, it connects them both. They fall down, they rotate, the rod pulls them together while they're rotating. All right. Sick. Okay, whatever happened there. Interesting. Wait, oh, yeah. So this wheel gets created, but the wheels are insanely small because that's how they start off sized. This image index or image scale is 9.9. So actually, before it was the wheel was bigger. Well, we'll start with 9.9 though. So each of these, actually in these wheels themselves, we can set the size there. So we're gonna go set size. Is there an MVP set size? There is not, so we can just set the size then. Image x scale is equal to 9. Duplicates is also the y. Press, that should be good. All right, that's too small of a wheel. The deadline was not 9 then, it was 18 maybe? Nice. Okay. Sick. Okay, let's see what happens here. We're gonna go. So they're good sized wheels. They're not far enough apart from each other. Like I guess in terms of the where they're placed in the car. What is this actually? What is this object? I must have created it by accident or something. I'll delete that. Okay. It's not referenced anywhere. Okay. So the car next up. Let's move it further away. So we'll just go 64. 64. I think it was a bit maybe a bit lower as well. So we'll just go plus 16, plus 16. Okay, then next we're gonna draw the actual rod itself too. I want to see how it looks. So we're gonna draw the rod. CG rod.draw. I don't think it requires anything yet because it has the rigid bodies already. Okay. And now instead of the wheel rotating by itself, we'll actually drive it ourselves. So this will be 0, and this is how fast it. Okay, we can add some acceleration to this. So we can go max rotation speed will be like 3 maybe. And we'll go rotation acceleration will be like 0.1. Okay. Okay, so we essentially are gonna calculate the rotation speed, right? That would actually be we would want to keep that then. So rotation speed right now is gonna be 0. Okay, so we want to first, so here's gonna be set angle. So very similarly to how you would do the movement stuff, where you would first calculate maybe a force, then calculate the acceleration, then calculate the velocity, and that velocity like translates to a position change. Similar thing to rotations. Calculate the rotations acceleration, which is already calculated. Now you have to calculate the actual speed and the velocity. So we'll go calculate rotation velocity. So we're just gonna go var rotation velocity. This is velocity because it has a direction. So it's gonna be I guess that's also true. Might as well make this rotation velocity. because this accounts for the direction. This is speed. Okay, so um, which means I guess we can just go like this then. As you go through, and we'll just go lerp. So we'll go from the current rotation velocity to the goal, which is going to be the max rotation speed, times the direction that you want to move. In this case, it'll be rotation direction. Let's see if that works. And then we'll just go rotation acceleration. All right, so you have the rotation velocity here. Say you, right now it's always to be 3. If you're not pressing anything, it'll be 0 though. So it'll alert to 0. If you, this is always going to be the same. If this is positive, it alerts to positive. If it's negative, it alerts to negative. Okay, should be okay here. And when we set the angle, it'll be this plus rotation velocity. All right, that should be fine. Now the actual driver, which is going to be the car. So the car's job is basically to set the rotation direction. Okay. So this, move two wheels, and we'll just go drive. Here we're gonna go front wheel, or I guess they were doing all-wheel drive here because they're driving both at the same time. So we'll calculate based off of inputs. We'll go var move x is equal to I prefer the letter keys to move, so I'm gonna go keyboard check pressed word D for positive minus the other direction, and that'll be A. Okay, move x, that's going to be a direction, and we're going to have to essentially make a rotation for that. Well, I guess we can just make a rotation direction. Rotation direction, and if it's the wrong direction, we just multiply by -1. You know what? We don't even need to make it a local variable. No, actually we do, because we're gonna apply it to both. So we're gonna go left wheel dot rotation direction is equal to rotation direction. Do the same for the right wheel. All right. So you calculate rotation direction, set it to the wheels, and actually move to the wheels as well. Okay. Let's see what happens. All right, the rotation speed's like really bad. Hold up, wait a second, what's happening here? Why is it not drawing the car either? Oh, because I'm not drawing the car. Here, so we're gonna go draw self. Okay, so rotations, let's see without the actual, here, something wrong here, rotation velocity, rotation speed. Before it was like, wait, do we? All right, let's just make it 1. This basically means that it'll go exactly to the max speed. So maybe 0.1 is too little. Oh, oh, that's why, Because I'm using pressed, I'm pretty sure. Yeah, I'm not sure why I did that. Okay. So that is every frame. You can go back to the, let me see, this, rotation acceleration. Okay, there you go. And I'm pretty sure it's going the wrong direction too. If I press right, I want to rotate left. Yeah, it's going the opposite direction. Okay. So I'm going to do the opposite way here. That would be car. That would be here. Times -1. Okay. And I think the acceleration is still a little too much, but we'll see what happens. Ah, no, go, 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 go. Okay. It is bad, but it's Oh, and it keeps going. It keeps going. Let's see. Is it pulling the actual rod? Interesting. The rod should definitely be pulling. What is the... Huh. It should change color though, if it's too long. Let's see what this one happens. Okay, it's red. Huh. Okay, so it is pulling. Why is it acting like a spring though? Huh. Interesting. Mm, okay. The rod definitely should. Let's make it a cable, see what happens. So I'm gonna go to the car and make a cable. So I'm gonna go. That's interesting. Okay, so there's nothing. Huh. Interesting. Am I doing something wrong here? Max length is 128. Oh, is there an extra? Oh, is that the rod? Um, hmm. That is interesting. I'm definitely doing something wrong here. CG rod and cable. So we create this, and I just realized why. Okay, I just realized why. That is my fault. I never linked these to the actual these things. Oh yeah, yes. Yeah. So MVP add contact generator. We're gonna go. Might as well do it with both of them. So with wheel or with wheel square. We're gonna go like this. We're gonna go self.id. Wait a second though. Oh yeah, I don't need to do this. Hold the phone actually. Huh. This should. I'm actually kind of confused here. Oh, because one of these, yeah, one of these is gonna not be affected. So it'll be left wheel to right wheel. The left wheel will be used as a reference. Yes. So the RB1 is used. Um, yeah, context. Oh, actually, no, that's not true. That's not true at all. That is not true at all. They'll both be used. Okay, so we just need to add them to one. I guess let's see what happens if we just add it to one. And we can probably make this, let's be this, that's good. And it's a rod still, okay. So it's the exact correct size in the beginning when it hits the thing. Okay, it crashes. Oh, we'll square the CG rod, that is correct, because we go other. And I'm going to go like this. There you go. Right, I mean, it's still like, there's the pull. There's the pool. Okay. I think we just make the wheels bigger. Let's make the wheels 22 because they just need there needs to be more center of like we're just yeah there you go. Okay, come on, go back, go back, go back. Come on, come on, come on. Yeah. Oh my gosh, it's so close. Okay, okay. Oh, it did it. Oh my gosh. All right, let's go. Okay. All right. I did what I came out to do. I made a car you can sort of drive. I did what I needed to do to make it move forward. So yeah, as you can see, there's like no friction applied to the surfaces. That's one of the things that I would like to add, obviously in the future, right? Along with just other things, of course. But yeah, that's how you make a car in nbphysics in GameMaker with square wheels. If I were to put like a bunch of other, I guess let's try putting a bunch of these with the heavy. Let's just put a bunch of these things. So these are all rocks. Different sizes would also be nice, but I'm not going to do that. Um, so this is basically the end here. I'm just gonna see what happens. If they're really heavy rocks that also can move around and are affected by gravity. All right, let's see. We're gonna go to the rocks again. We're gonna do here point 0.001. We're gonna that's like insanely heavy. We're gonna go and make the damping again low. We'll make it not that low. We're gonna also make the gravity go downwards. Gravity dot y is equal to 10. Same gravity as the others. Okay. Press play here, and let's see what happens. They're all asleep too. Sick. Let's go. Okay, that's so cool. All right. But yeah, there's also yeah the fact that there's no actual torques being generated or anything. This is all about like the collisions just being resolved based off of the position of the object. So that's why it's even possible to do this. But yeah, that's it. That's all I have right now. So yeah, a little preface, I guess the this series is sort of gonna be like this. There's gonna be like little ideas. I'm just curious to see if it's even possible to do. Let me see if I'm recording. Okay, I'm recording. All right. Yeah. So a couple other ideas I'm gonna probably do like a rope bridge. Curious how that would look. And just other things as well. But yeah, that's how you make a yeah. I already said that. So I guess I'll see you in the next video. Bye.